Hi everyone, this is Mrs. V. Chan. Welcome to my Form 2 Math lesson number 16. Today is 11th May 2020. Alright, so today's topic we have trigonometric identities. Okay, let's look at this right angle, the triangle, and here is angle theta. Alright, so remember what is B to this theta, which is the adjacent side. Okay, so therefore A is the opposite side to theta, is that right? And what do we call the longest side for a right angle triangle, which is the hypotenuse? Okay, so let us do revision first on sine theta, cosine theta, and tangent theta. Okay, so remember the formula for sine theta. Sine theta is equal to the opposite side divided by the longest side, which is hypotenuse. So therefore, we have the opposite side, which is A, and then C is the hypotenuse, right? Right, okay. And then cosine formula is the adjacent side over the longest side, which is the hypotenuse. So now we have in this diagram, adjacent side is B and hypotenuse is C. How about tangents? Tangents, the formula is opposite side over adjacent side. Alright, so therefore, we have this opposite side is A and then adjacent side is B, right? Well, we have learned that before. Okay, now we come to the relationship between the sine, cosine, and tangents. So how about sine theta over cosine theta? So therefore, I will have this sine theta as A over C. And then over means divided by, and then I change this to B over C. So divided by B over C, I have to flip over the denominator and the numerator. Okay, so therefore, for this C and C cancel out, I have this A over B. Okay, and then you realize that this is sine theta over cosine theta, which is A over B. And what about tangent theta, which is also same as A over B? Therefore, we can have this conclusion saying that tangent theta is always the same as sine theta over cosine theta. So this is the first identity we have in today's lesson. Okay, that means it is always true on the left-hand side. Tangent theta is always the same as sine theta over cosine theta. Okay, or we can prove that in another way. So what is the value of 45? Tangent 45, which is equal to 1. Okay, and then look at what is the value of sine 45 over cosine 45. Alright, so the sine 45, the value for sine 45 is root 2 over 2. And cosine 45 is also root 2 over 2. So therefore, when you have the same numerator and denominator, so the answer is equal to 1. Once again, we can say that, therefore, tangent 45 is same as sine 45 over cosine 45. So this is the first identity we have in today's lesson. Okay, next, let's look at the value of sine square theta plus cosine square theta. So here I have my sine theta, which is equal to A over C, so all square, and then plus. How about cosine square theta? So cosine theta is B over C, all square. Therefore, I simplify this expression, so that would be A square over C square, and then plus. This is B square over C square. So now I have the same denominator. I can simply put this C square and then combine them, A square plus B square. Alright, so what is A square plus B square? Remember that this is a right angle triangle. Alright, so A square plus B square is same as C square. So which theorem do we use here? So I write it down here. So A square plus B square is equal to C square. Alright, remember the theorem, which is Pyth dot Pythagoras theorem. Right, so therefore, A squared plus B squared is C squared over C squared. So what is C squared over C squared, which is equal to 1? Okay, so therefore we can say that sine square theta plus cosine square theta is always equal to 1. So this is another identity we have in this chapter. Okay, we can do some exercise. Now let me change this theta. Let's say it is 30, for example. So how about sine square 30 degree plus cosine square 30 degree? Okay, so this is special angle, right? Square sine 30 is 1 over 2. And then I need to make square here. How about cosine 30 is also, no, cosine 30 is root 3 over 2. Alright, so this is all square, so 1 over 4 plus root 3 square is 3, and then this is 4, so what is it? 4 over 4, so the answer is 1, right? So which is exactly same as this sine square theta plus cosine square theta is equal to 1. So therefore in today's lesson we have two identities. One is tangent theta is the same as sine theta over cosine theta, and then another one, sine square theta plus cosine square theta is equal to 1. Alright, but sometimes you will find it very useful. You can change subject to sine square theta, therefore that will be equal to this 1 here, and move cosine square theta to the right hand side, so minus cosine square theta. So we just change subjects, and then you will find it very useful as well. So now we can change subject to cosine square theta, and that will be 1 minus sine square theta. Okay, so later on we are going to use all these identities to do our exercise in this chapter, and then I add another one here. Tangent theta is same as sine theta over cosine theta. So therefore we are going to have this all together in today's lesson. Alright, so here we have example 1. We need to simplify this sine square theta over tangent theta cosine theta. Alright, so let us split this tangent theta into sine theta and cosine theta, so that I have this cosine theta, is that right? So therefore this tangent theta actually is the same as 1 over tangent theta. Okay, next I just copy this, and now I can split this 1 over, so tangent theta is equal to sine over cosine. Now I have the flip over, I put cosine up, and then I have sine here. Okay, so what's next? This cosine and cosine cancel out, and now I have this sine, and then this is square, no more, so what's left? I have sine theta. So this is how we simplify this trigonometric expressions using identities. Okay, how about this one? 2 sine square theta plus 2 cosine square theta. Is there any common factor? Yes, 2 and 2 is the common factor, so I can do factorization. I remove these 2 out and then use bracket. Therefore, what's inside? I have sine square theta inside the brackets plus cosine square theta. Therefore, remember what is sine square theta plus cosine square theta, which is equal to 1. So 1 times 2 is 2. Okay, so this is it. Okay, how about this one? So 1 over 1 plus sine theta plus 1 over 1 minus sine theta. Okay, this one is a little bit complicated. So when we do this sum of fraction, for example, I'll give you this example. Let's say, how do you do 1 over 3 plus 1 over 5? Okay, the first thing, you have to find the LCM of 3 and 5, which is 15. This is 15, is that right? And then how do you change from 3 to 15? You enlarge it by 5 times, so that is 5. And then for this, you enlarge it by 3 times. Therefore, since you have the same denominator, and then you can combine them together, so this is the answer. Is that right? Okay, so to combine these together, similarly, we need to work out the denominator, the LCM. So therefore, what is the LCM here? Will be 1 plus sine theta times 1 minus sine theta for the first term, and then plus another term, also 1 plus sine theta, and then 1 minus sine theta, right? Okay, so how do you change from 1 plus sine theta and then you times this, the new thing here? So therefore, I need to put this on top. 1 minus sine theta. Okay, so what is the new thing for this second term? So this is a new thing. So therefore, I have 1 plus sine theta. Right? Okay, so since now I have the same denominator, I can combine them together. So I will have 1 plus sine theta and then times 1 minus sine theta. So what do I have on top? That will be 1 minus sine theta plus 1 plus sine theta. Oh, very good here. Minus and plus no more. Therefore, oh, I missed out the bracket here. So therefore, what is the answer? What is the answer to that? So I have 2 on top, and then there will be 1 plus sine theta, and then 1 minus sine theta. Right. And actually, we can still go on with the simplification. Remember one of the identities in the first term, for example, what is x plus y times x minus y? Remember this identity, which is same as x squared minus y squared. Therefore, for the denominator here, obviously, 1 plus sine theta and then 1 minus sine theta, which is 1 square, which is 1, minus sine square theta. Okay, so therefore, what do I have on top? Right, okay. So what is 1 minus sine square theta, which is same as cosine square theta, and then this is 2 on top, and therefore, this is the final answer. Okay, so if I go back to my identity table, so here 1 minus sine square theta is same as cosine square theta, so therefore I can make my final answer here 1 minus sine square theta, same as cosine square theta. Alright, so that's all about point C. Okay, so here we have example 2. To simplify this, 3 minus 2 sine square theta minus 2 cosine square theta. So let us group this together using brackets. So that will be 3 minus, and then also 2 and 2 is the common factor. I can make this 2 outside the bracket, and be very careful since this is minus. When you add bracket, you must change the sign inside the bracket. So that will be sine square theta plus cosine square theta. Okay, so this is very good because sine square theta plus cosine square theta is equal to 1. So therefore we have this 3 minus 2 times 1 is 2. The final answer is 1. So how about this one? We have 1 over sine theta cosine theta minus cosine theta over sine theta. So if we want to combine them together, we must find the LCM. So what is the LCM for this? So we already have sine theta here. So repeat sine theta, and then no cosine theta, so we add cosine theta. So this is sine theta and cosine theta like that. So from here to here, no change. So I have 1 on top. But what is the new thing? I missed out the theta here. So what is the new thing here? We already have sine theta here. The new thing is cosine theta. So therefore, I will need to have cosine square theta. So since I have the same denominator, I can join them together, sine theta, cosine theta, and then on top I have 1 minus cosine square theta. Okay, what is next? What is 1 minus cosine square theta? We remember one of the identities, which is sine square theta. Therefore, I have sine theta here for the denominator. Okay, and sine theta, and that is square, cancel out. So what's left? Sine theta over cosine theta. So final answer is same as tangent theta. So done. This is how we simplify, okay, the expression by using trigonometric identities. Okay, so next we do something different. That is, we are given this, it is already identity. That means the left hand side is exactly same as the right hand side. However, we don't know. We have to prove it. Okay, so whenever we need to prove something, don't forget we must separate the left hand side and the right hand side. Okay, so we start from the left hand side. I just copy that again. So left hand side we have tangent theta, cosine theta plus sine theta. Okay, and then I can split my tangent theta here, so that is cosine theta on top. I split my tangent theta into sine theta, cosine theta, right? So therefore this is what? This is the tangent theta. Okay, and then plus sine theta. Okay, just do it step by step. So therefore what happened? This is sine theta, cosine theta, and over cosine theta, so I can make this cosine theta and cosine theta cancel out. So therefore this is sine theta plus another sine theta. So altogether how many sine theta? Which is 2 sine theta. Okay, look at that. On the right hand side, which is also 2 sine theta, so RHS right hand side. Okay, so therefore it is an identity. Okay? Okay, so next we have another identity that we need to prove. So once again, always remember to separate the left hand side and the right hand side. Okay, so on the left hand side, I have this cosine theta minus sine theta all square. Okay, so which identity we use in the first term? For example, so what is x minus y all square? Remember that? So the identity is same as x squared minus 2xy plus y squared. So we need to use that identity. Okay, so to do this, I can do this. So something square minus 2, right? Oh, sorry, so plus. Right, this is the bracket, so that I will have this cosine theta all square minus cosine theta, sine theta, and this is plus sine theta. Okay, so I need to modify a little bit. So very often we put cosine square theta. Very often we put this in the middle so that I cancel out the bracket here. Alright, and also usually when we show this square, we put it in the middle. Okay, you just ignore the brackets. Therefore, what do we have? So this is cosine square theta, sine square theta, which is, okay, I rewrite it one more time, plus sine square theta, and then I have this minus, okay, I change this, the order, 2 sine theta, cosine theta, right? And what is this? Sine square theta plus cosine square theta, which is equal to 1. So 1 minus 2 sine theta, cosine theta. Let's check on the right hand side, which is exactly the same as the right hand side. Okay, so conclusion, therefore it is an identity. Alright, so this is the final question to finish today's lesson. So again, we need to prove this whether it is identity or not. So on the left hand side here, this is 1 plus tangent theta for denominator and 1 minus tangent theta. Again, we need the LCM for that, so I just copy that one more time. Okay, and what is LCM? That will be 1 plus tangent theta and then 1 minus tangent theta plus, okay, no more ink, and then 1 minus tangent theta. Okay, so to look at that, so what is the new thing for the first term? This is 1 minus tangent theta, so therefore I have 1 minus tangent theta on top. And then check the second term. What is the new thing? This is a new thing, therefore I have 1 plus tangent theta. So since I have the same denominator, I can combine that together. That would be 1 plus tangent theta and then times 1 minus tangent theta. You just do it step by step. Okay, so actually I can have this cancel out, minus tangent theta and then plus tangent theta. So what's left? 1 plus 1, which is 2. This is 2. So again, I can use identity. So I write identity again here to remind you. So that is x plus y and then x minus y, which identity we use, that is x squared minus y squared. Okay. Okay, so 1 square is 1 minus tangent square theta. Okay, so 2 over 1 minus, we can split this tangent square theta into sine, cosine, so that would be sine square theta over cosine square theta, right? Okay, again, I have a fraction here, so I can change 1 into, this is cosine square theta, this is sine square theta, right? And then this is cosine square theta, so make it the same as 1, so this is also cosine square theta, so that is 2. Okay, like this, so 2. So since I already have the same denominator, I can have cosine square theta here and combine them together, cosine square theta minus sine square theta. However, what is meaning of 2 over this is same as 2 times I flip over that. Yes, I write it one more step, divided by. Okay, I give you one more step to show you. So over means divided by. So if I change that to division to multiplication, I need to flip, right? Okay, and this is sine square theta. Okay, finally, what is it? So finally, what is it? So that would be 2 cosine square theta, and then here I have cosine square theta minus sine square theta. And let's check the right hand side. The right hand side here, 2 cosine square theta, and then over cosine square theta minus sine square theta. See? 2 cosine square theta over cosine square theta minus sine square. So this is same as what? The right hand side. Okay, this is it. So we have proved it, which is an identity. Okay, so let us go to the identity. Finally, go to the identity table, all identities here. All right, so here we have all the identities that we need to use to prove or to simplify the expression. Okay, so thank you for watching my video. I'll see you next time. Bye-bye.